Hello, how are you? Hello, how are you? Hello, Julian. Hello, how are you? You fine? We're waiting just 30 seconds to all of you to connect. Please, you have to be with you your notes about natural science, Unit 5. I want to explain heat or thermal energy. Just 30 seconds. Are you fine? All of you? Your families? I hope. Okay, so let's get started. Now, today we're going to talk about heat energy. Heat energy is the same as thermal energy, and you have in your notes there this first part. This is very easy. We're going to deliver this class with a mix of your note, your text part, your exercise part, and three videos that I brought to you, and you have in your email. Okay, good. So first thing you need to remember is that heat is the same as thermal energy, and you have to remember the last theme where we saw that there are many forms of energy, many of them. Um, there is something that you need to remember, that energy can't be created nor destroyed. We can't create energy. We can't destroy energy. So what can we do? We can transform one form of energy into another one, or we can store energy. So this is the thing. And heat energy is the energy that is due to heat. And to understand this properly, you need to take a look to this scheme. So thermal energy or heat energy is energy in the form of heat. And this heat is generated by the movement of tiny particles within an object. And you have to know that the faster these particles move, the more heat is generated. And now we're going to watch a kind of video about heat energy and about the movement of particles. This is the second video you have in in a file that I sent you out to you this night. So you can see it in YouTube. This is a kind of advertisement. Okay, and pay attention.
Do you know what water, air, and rocks all have in common? They are made of matter. Matter is something that takes up space. Now, you might be wondering why they all look so different if they are made of the same thing. But the truth is that everything around you is made of matter, just in different shapes and forms. Matter is made of tiny particles called atoms. Matter can be grouped into three main states: solid, liquid, or gas. To figure out which state of matter something is in, we need to examine its properties. A property is the way that something is that we can measure. The physical properties we will look at to determine state of matter are shape, mass, and volume. Mass is the amount of matter in an object. Volume is how much space that matter takes up. Solids are easy to recognize. Rocks, apples, pencils, and plants are all examples of solid objects. A solid object has a definite shape that doesn't change when you move it or put it in a container. They also have a consistent mass and volume. This is because the atoms in a solid object are packed closely together, so they do not move around. A solid will change shape only if forced, for instance, if it is broken or smashed. If you look around, you can find many examples of solid objects. Liquid is the next state of matter. Liquids have a definite volume and mass, but they do not have a definite shape. The atoms in liquid are still close together, but unlike the atoms in a solid, they can move around. This allows the matter in a liquid to flow. Because liquids don't have their own shape, they take their shape from their containers. The same amount of liquid may look very different in a glass and spilled on the floor. You can find examples of liquids around you too. Water, milk, and juice are just some of the liquids you might find. The third state of matter is gas. Gases have a definite mass, but they do not have a definite shape or volume. Like liquids, gases take the shape of their containers. Unlike liquids, gases will spread out to completely fill the container they are in. If a gas is not in a container, it will keep spreading out indefinitely. This is because the atoms in a gas are farther apart than atoms in a solid or a liquid, and so they can move freely. The air you breathe is an example of a gas. You might have noticed that you can't really see air. Often, gases are invisible, but they are still there. There are many different types of gases in the Earth's atmosphere, like oxygen, nitrogen, carbon dioxide, helium, and water vapor. Sometimes matter can change from one state to another. Water is a very good example of this. When water is frozen into ice, it is a solid. When it melts back into water, it is a liquid. When water evaporates into water vapor, it becomes a gas. Matter in all its states is everywhere. See if you can find solids, liquids, and gases around you.
Good. So this is our video. I brought this video to you because the difference between a solid, a liquid, and a gas has to do with the particles, how close these particles are, and they are close in function of their energy, okay, in form of the movement. Okay, so now go to the next part. So we're talking about moving particles. That is the clue to differentiate a liquid or a gas or a solid. And you have there 4 different paragraphs. In the first one, you have there matter is made up of tiny particles called atoms. You know that, and molecules. And these particles are moving all the time, so they have energy. Okay, some kind of energy. When a substance heats up, the rise in temperature makes these particles move faster and bump into each other. And then it is the motion of particles that creates heat. That is the same as thermal energy. So atoms and molecules can move because they have some amount of energy. And this energy is what gives this solid, this liquid, this gas heat energy. And you have to remember something that is very important. The hotter the substance, the more its particles move, and the higher its thermal energy. And now you have to move to your exercise part. And sorry, this is for you. So we want to try to do to and correct the first exercise. And you have there a text. So talking about heat or thermal energy. And you can see these particles there. So solid, all these particles are packed together, tightly together. Okay, they can't move. That's why a solid keeps the same shape always. You move here, you can see a scheme about the particles in a liquid. Particles in a liquid have a kind of energy, and they can slide across each other. In gas, you have here the particles in a gas, they can move freely. They tend to occupy the more space that is possible. So you have here this text, and I'd like you to take part in this correction. So I want to read, and you have to write what you consider that is the answer, the correct answer. So we're going to start. Tiny particles in solids, liquids, and gases are always, and we have to choose between always still, always in motion, always visible. What do you think the correct answer is? Are they visible always? No. Are they still? No. They are in motion. Okay? In motion. You know. So if you are talking about a gas, the motion is free. You're talking about a liquid, the motion is not so free. They have some motion. You're talking about a solid, the motion is very tiny. Good. Next. It is the motion of particles that creates a form of energy called thermal, or and you can choose between sound A, heat B. You only have to write the A, B, or C. Only that in your chat. Only that. Sound A, heat B, light C. Talking about thermal energy. A synonym with thermal energy is sound energy, do you think? I don't think so. Light energy? I don't think so. Heat energy. This is the correct answer. Very good. So, now, the particles in are tightly packed and can only vibrate. We're going to select between gases, liquids, and solids. They only can vibrate. They don't have a free movement. So we're talking about gases A, or liquids B, or solid C. What do you think? Yes. Solids. So the particles in solids are tightly packed and can only vibrate. Now next. The particles in number 4 also vibrate, but are able to move around by rolling over each other and sliding around. And we have to choose between number 4, between liquids A, solids B, or gases 3. What do you think? Particles that can vibrate but can slide past each other. Can't be solids, so we have to choose between gases or liquids. And the correct answer is yes, A, liquids. Good. Next, in the particles move freely with rapid random motion. Rapid, okay? Very fast. they move very fast. So the correct answer, very good, very good, very good. You have guessed correctly, are gases. So number 5 is gases. Very good, very good. And we have here the exercise number 2. But before, I want you to watch another video clip about this theme. So, pay attention. This is a very short video clip. Pay attention.
Solids, liquids and gases. It's really important that we understand how to explain the 3 states of matter in terms of their particles. So, on screen we can see a solid, a yummy ice lolly, a liquid, a tasty can of cola, and a gas, which is inside the pretty balloon. So, let's look at how the particles are arranged in each one. Firstly, the solid. As we can see, the particles are really close together. They're in a really nice, ordered structure, and also they're only vibrating. This is because the particles don't have enough energy to overcome the bonds holding them together. Now let's look at the liquid. As we can see, they're still really close together, they're all touching, but they have enough energy just to slip over the top of one another and move about, partially overcoming their bonds. There's also no order here whatsoever, with the particles constantly shifting and moving about. Finally, a gas. Now the particles have enough energy to completely overcome their bonds, and they're moving around all over the place. Again, there's no order here, and the particles are all free and separate to move. So what do you need to know? Well, you need to know that in a solid, the particles are all touching and in an ordered fashion. In a liquid, the particles are still all touching, but they're ordered in a random fashion, and there's occasional pockets where they can slip over one another. And then a gas, they're again in a random fashion, and this is really important. You need to make sure when you draw this, you don't draw them in an ordered structure at all, and they're really, really far apart from one another. It should be also quite easy to see from these that gases take up much more space than liquids, which again take up more space than solids.
Very good. Very good. So, is it easy? I think it is. So, let's go to the exercise number 2. Oh, sorry. There's something here I have to... Okay, good. Let's go to our exercise. So, now, number 2. These sentences are about thermal energy. Say true or false. You can take part here. So, number 1. Heat energy is another name for thermal energy. What do you think? Yes, that's true. Good. Number 2. Heat is the transfer of energy from one object to another due to a difference in temperature. So you are hotter, you can transfer your heat energy to another object that is cooler. Remember that this is the same. Okay, so what do you think? True or false? Yes, true. Number 3. Thermal energy comes from a substance whose molecules and atoms are vibrating more slowly. Remember, if they vibrate slowly, they have less energy than if they are vibrating faster. Remember that. So, the correct answer is that this sentence is false. Correct? Good. Heat can be measured in joules or in calories. Joules is this is a word, kind of unit to measure heat. So this is right. Okay, heat can be measured in calories. Okay, so this is a thing you have to look. You have to check when you are eating any food. You have there kind of tag with the name, with the number of calories each food contains. Good. Let's move. Number 5. Thermal energy is produced when a rise in temperature causes atoms and molecules to move faster and collide with each other. So thermal energy is produced when a change of temperature goes to some particles and makes them to move faster. You think? Yes, this is true. Number 5 is true. Now, number 6. When something gets hotter, it will expand or get bigger. When something gets hotter, it will expand. Okay? Or gets bigger. What do you think? And the conversely is true as well. Yes, this is true. So number 6 is true. Number 7. When something gets colder, it will shrink. Shrink is the English for our Spanish encoger. So when something gets colder, it will shrink. And this is true as well. This is true as well. 8. Thermal energy is not related to the temperature of an object. So according to this sentence, it doesn't matter the temperature. It doesn't matter the temperature to study thermal energy. And this is clearly false. This is false. So number 8 is false. Number 9. When you add ice to a warm drink, some of the drink's thermal energy is transferred to the ice, which makes the drink cooler. No, it's the other way around. Okay. So when you add ice to a warm drink, it is the drink. If the drink is at a higher temperature, it's the drink, the molecules of the drink, that gives the energy to the ice. That's why the particles of the ice that is solid start vibrating faster and faster and faster, and it turns into liquid. So this sentence is false. Very good. And finally, number 10, heat and temperature are the same thing. Be careful. This is clearly false. I want to talk about that now. So go again to the text part. Now, heat and temperature. Heat and temperature are not the same thing. Okay? Many people mistake heat and temperature, but these are different things. They are related together, but are different things. The difference is that, and you have to understand that, and you have to learn that. Heat is a form of energy. Temperature is not a form of energy, but heat is. So heat is a form of energy created when atoms and molecules inside an object move. This is heat. So imagine the sea. Okay, when you are taking a bath in a beach, imagine the sea. Okay, the immense sea. So a lot of particles there of water, and they contain a lot of heat energy, but the temperature is really cold. Okay, this is the difference. So heat is kind of energy, and temperature. The temperature of an object is how fast its molecules are moving. Okay, so if you take a shower, your molecules are moving or vibrating faster than the molecules of the water of the shower. Very good. And then the next page you have this part. So a thermometer is an instrument used to measure the temperature of an object. As you know, this is easy. Good. The temperature is measured in degrees Celsius or Fahrenheit. Celsius is normally the scale we use in Spain, in France, in Italy, normally in Europe. But Fahrenheit is the scale that is used by English people, American people in the United States. Okay? So they are two different scales of temperature. One of them is called Celsius. This is ours. Okay, the same. This is the, in the sense that this is the kind of scale we normally use. And Fahrenheit, this is the scale that people in the States or people in Britain normally use. So Celsius and Fahrenheit is the name for two different scales. We have in class, you remember in class, we have a thermometer just on a wall, okay, with the two different scales, Celsius on one side and Fahrenheit on the other side. Okay. And objects that have a high temperature are hot, and objects with a low temperature are cold. I think this is easy to understand. And now, to support this content, you have another video. We're going to watch it now. So I remind you that you have all this video at your disposal because I sent you. Oh.
Heat energy. Everyone probably knows something about heat. We often use the word to describe something that feels hot when we touch it, or to describe a hot day. To fully understand what heat is, we first have to understand something about energy. Energy has to do with the movement of the particles that make up matter. If we were to look up close at the particles of something very cold, we would see them moving very slowly. If their movement is very slow, they have less energy than the particles that make up something that is hot. For example, particles of hot water in a pot would vibrate very quickly, so they would contain lots of energy. Heat is actually a form of energy that is being transferred from a substance at a higher temperature to another substance or substances at a lower temperature. Have you ever touched a hot pot that was on a stove? What happens when you touch it? It burns your hand because the heat energy is transferring from the hot pot to your hand. Your hand had a different temperature than the hot pot. Your hand was much cooler than the hot pot. Heat energy always travels from a hotter substance to the colder substance. In this case, it travels from the pot to your hand. Think about what happens to a mug of coffee when you pour hot coffee into it. The mug felt cool at first, but then felt hotter as you poured the hot coffee into it. The hot coffee transferred its heat energy to the mug, which was cooler. Heat is not the same as temperature. Have you ever used a thermometer to measure something's temperature? Temperature is a measure of the energy that matter contains, or how hot or...
Sorry, can you see here? This is the scale of in Celsius degrees, and this is the scale in Fahrenheit degrees. It's different. Okay, so imagine today we are at 15 Celsius degrees. Okay, in Fahrenheit, this is below zero. Okay, this is different. It's different. Okay, let's continue.
Cold it is. So, when you use a thermometer, you are measuring how fast or slow the particles in matter are moving. The faster the movement of the particles in an object, the higher the temperature of the object will be. Heat, once again, is the transfer of an object's energy to another object with a lower temperature. Heat energy is something that is very useful to all living things. In fact, no life would be possible on our planet without the light and heat energy from the sun. The sun makes it possible for all plants to grow. Plants, in turn, are needed by living things to consume. When we're in our homes or schools, we use heaters. These heaters heat the air right above them and eventually transfer this heat energy to the rest of the air in the room. This works in a way quite similar to how an oven transfers its heat to a bowl of liquid kept in it. The hot bowl transfers its heat energy to the liquid being heated. Toasters and coffee makers are two other sources of heat energy found in our homes. Can you think of any other source of heat energy? A fire of any kind is a source of heat energy. If you go camping, a fire will provide a nice source of heat energy on a cold night. A gas stove has a flame that is the source of heat for warming things up. Our own bodies produce heat. You can tell this by holding a piece of ice. After a few minutes, the heat energy from your body is transferred to the ice, causing it to melt. A bathtub that is filled with hot water can transfer its heat energy to a person who needs to be warmed up. Heat energy can be used for many things. The most obvious is for keeping us warm in our homes and cooking food on our stove. As mentioned before, a hot bath can be used to warm up our bodies. Heat energy is also used by plants to make food for themselves. In some places, there are hot sources of water found deep within the earth. These can be used as a source of electricity. When hot water is used to make electricity, this is called geothermal energy.
Pay attention to this scheme, okay? Because in the next unit, unit number 6, we're going to talk about electricity, and we're going to study all this scheme. Okay, so pay attention. Okay, and keep that in mind. Let's continue.
Here is the summary of the lesson.
So heat energy always travels from a hotter substance to a colder substance. And another important thing you have to remember is that temperature tells how hot or cold a substance is. Okay, and we use the thermometer, okay, as a tool to measure the temperature. Heat energy is useful to all living things. Okay, we need sun to survive. Other sources of heat energy are heater, gas stove, fire, and many others. And we use heat energy for cooking food, to warm ourselves. You know all these things. Okay, very good, very good. And now let's go to our text part. So the thing you need to do today is to read about heat and temperature. Okay, only that, heat and temperature. And you have here down on the page number 2, you have these two definitions. They are very important for you to understand the theme, the difference between heat and temperature, and then this part about the thermometer. Okay, having done that, you have to go to the next to the exercise part, and you have there the exercise number 3, that is about temperature and heat. You have to read this text. You have to understand this scheme. Then you have to finish this text, and below you have 5 questions. I want you to answer these 5 questions, but in good English. Okay, in good English. Good English means you need a subject and you need an object. Not too many words, but you need good English, good spelling, and all these kind of things. Very good. And only that. Okay, only that. As to natural science, only that today. And you have more work about maths. Okay. Very good, very good. So this is the end of our class today. I hope you like it. And remember, we are in a moment very important. We are finishing our term. We need to work hard and harder, because in less than 2 months' time, when finishing this course, okay, this is very important. You have to make the most of your time at home. Okay, okay, very good. Don't get relaxed. Don't get relaxed. You have to work all days. And now, this is the end of our class. I want to finish this class, and I don't know how to finish this.